All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. Right, let us start discussing few problems related to the equations which we discussed. The equation which we discussed, what is the condition? Main condition is acceleration has to be constant, right? So first question, an object having a velocity of 4 meter per second is accelerated at a rate of 1.2 meter per second square. So they said it is a velocity, so it's obviously initial velocity, right? When it is starting, okay, that is what it is starting at 4 meter per second, and it at a rate of, that is at an acceleration of 1.2 meter per second square when time is 0. Okay, when it is starting, velocity is 4 meter per second, so it is initial velocity, and after 5 seconds, so time taken was 5 seconds, and they are asking after 5 seconds, they're asking what is the distance traveled, that is yes. Okay. So what is the best equation? I have initial velocity, I have acceleration, I have time taken. So the best equation could be S is equal to ut plus 1 by 2 at square. Can I use this equation? Can I use this equation? Of course I can use this equation because acceleration here is constant, which is 1.2 meter per second square. So that will be equal to, initial velocity is 4, time taken was 5, okay, 4 into 5 plus 1 by 2 into acceleration is 1.2 into time taken was 5 square. So just this will become 20, this will become 25 into 1.2 in 1.2 by 2, so that's going to be 15. So 20 plus 15, it's going to be 35, and it will be in meters. Okay, so the correct answer for this question is 35 meters. A particle start from rest, which means time taken was 0 second, and moves along a straight line. It's a rectilinear motion with a constant acceleration. As we know that constant acceleration means I can use the three equations which we derived. If it acquires a velocity 10 meter per second, so if it acquires a velocity of 10 meter per second, after traveling a distance of 25 meters. So it is traveling a distance of 25 meters, and then it is achieving a velocity 10 meter per second. Okay. Now they are asking what is the magnitude of acceleration. So this is something which is very, what I could say, straightforward question only. We know final velocity, we know the speed, sorry, we know final velocity, we know the distance. How to find out the magnitude? That means how to find out the acceleration. I hope we can use this, right? V square minus u square, or in other sense, v square is equal to u square plus 2 times of as. I can use this equation. They clearly mentioned a particle starts from rest. So when it is starting, that is at 0 seconds, it was at rest, which means initial velocity was 0 meter per second. Okay, so this is a clue which is there in our question. They said it is rest, so initial velocity was 0. So initial velocity is 0 now, so this becomes 0. 2 times of acceleration is unknown. Distance was given as 25, and final velocity is 10, which is 10 square, which is 100. So 100 by 2 into 25, that will be my acceleration, which is simply 50 by 25, which is 2. Okay, so which is option A. So next question, a car is moving with a uniform acceleration. So what did this mean? Acceleration was constant. Okay, acceleration was constant for the car which is moving. It covers 450 meters in 5-second interval. Okay, so in 5-second interval, okay, in 5-second interval, it covers 450 meters. Okay, and 700 meters in next 5 seconds. Okay, so next in the 5 second, it is covering 700 meters. Okay, so time taken initially 5 second, and for this also 5 second, and total time taken will be 5 plus 5, which is 10 second. Okay, which is nothing but t1 plus t2. Okay, so s1, that is initial distance covered, was 450, and s2 was 700 meters. Okay, now the question is, they are asking about the acceleration of the car. So they are asking about constant acceleration A. We can use any one of the three equation, but what equation I will use? See, we know S, we know T. Okay, so let me take, this is point 1, this is point 2, this is point 3. Did they mention anything that the car is starting from rest? Was there anything which is mentioned like that? Of course not, right? Of course not. So which means there is a possibility for some initial velocity. Okay, because they didn't clearly mention whether it is zero or not. So there is a possibility for some initial velocity u. Okay. So we don't know what is u also. So u is also unknown, a is also unknown. Of course, final velocity is also unknown. Now, if I take only this section, okay, if I take only this section, what are the unknowns? U is unknown, acceleration is unknown, and the final velocity here, okay, v2 is also unknown. Okay, three unknowns are there. And why I need to unnecessarily go for the third unknown? I will just use this two unknowns, and I already have two knowns. I will try to frame one equation from this. So what equation I can frame? Simple, S is equal to ut plus 1 by 2 at square. See, I'm going to use this formula. You can use the other two also. By using that, you can do. There is a possibility that the problem will be extended. Like it will be somewhat big, but you can solve in different ways. I'm using this formula because the straightforward reason, I know S, I know T. Okay, so there will be only two unknowns. If I take any other term, there is a possibility for more than two unknowns. That is why. So here first I'm using for 1, right? So S1 is equal to U1. I'm going to take it as U only. Okay, I'm just going to take it as U only. So U into T1 plus 1 by 2 A into T1 square. Acceleration is constant, right? Acceleration is constant. So S1, which is 450, which is going to be equal to U, which is unknown. Time taken was 5 seconds plus 1 by 2 into acceleration, which is constant A, and time taken T1, which is 5 square. So this is going to be 5u plus 5 square by 2, which is 12.5a. Okay, which is 450. I will keep this equation as 1. Okay, so now I got one equation, right? So in this one equation, two unknowns are there, u and a. Okay, so now I will try to frame the second equation such that in the second equation also u and a are unknown. Then only I can solve two equations, right? Two unknowns, I can solve it. So that what I can do now, what equation I can use? I'm going to use the same s is equal to ut plus 1 by 2 at square equation. Now I'm going to take a distance from 1 until 3, total distance. If I take total distance, it is 450 plus 700, which is 1150, which is equal to, what is the initial velocity? Initial velocity is u only, right? Initial velocity u only. Time taken is the total time taken, which is 10 second, plus 1 by 2 into acceleration into again time taken, which is 10 second, 10 square, which is going to be 1150, 10 times of u, plus this will become 50 times of acceleration. Okay, so now how can I convert this, or how can I solve this? Simply I will multiply equation 1, okay, equation 1 with 2, okay, equation 1 with 2. So this left hand side will become 900, this will become 10u, and this will become 25a. Okay, now let me subtract them. So these two will get cancelled, and if I subtract them, this is going to be minus 250, this is going to be minus 25a. Minus minus anyways will get cancelled. So finally the answer which I'm going to get is going to be 10, what is that? Yeah, it is 10 meter per second square. So acceleration is 10 meter per second square, which is option B. So next question, they given that a particle start with a velocity 2 meter per second. So initial velocity is 2 meter per second. So let us consider a particle is starting here. Okay. And the initial velocity is given as 2 meter per. So initial velocity is 2 meter per second and moves on a straight track with a retardation. Okay. So straight track, it is moving on a straight track with a retardation of 0.1 meter per second square, which means minus 0.1 meter per second square. This is retarding. This is not accelerating. Since it is retarding, velocity will continuously decrease. Okay. Now they are asking time after which the particle is 15 meter away from the starting point. Okay, let us consider this is the point which is 15 meter away. Okay, which is 15 meter away from the starting point. Now they are asking time corresponding to this 15 meters. So distance is given as 15 meters. So simply we know distance, we know initial velocity, we know acceleration, and we need to find time. What formula I can use? It's very straightforward. S is equal to ut plus 1 by 2 at square. Right, very straightforward. Why? The reason is they given everything, right? They given S, they given U, they given A. So the unknown is T. If I use this formula, I can easily find out. Okay. Now what about S? S is 15 and U is 2 into time taken, which I don't know, 1 by 2 into acceleration is minus zero point 0.1. This is T square, not an issue. Okay, so I will just bring everything to one side. Okay, so I will just take this also that side, this also that side. So it becomes 0.1 by 2 into t square and minus 2t, and this is going to be plus 15, which is going to be 0. 0.1 by 2 is nothing but 0.05, right? So let me erase it and let me write it 0.05. I can simply use that formula. This is A, this is B, this is C. So if I want to find t, minus b plus or minus root of b square minus 4ac by 2a. Okay, so a is equal to 0.05, b is equal to minus 2, and c is equal to 15. Okay, just take this and substitute it here. Okay, so if I do that, I will be getting the answer. So by solving this, you will be getting 30 seconds, comma 10 second. Okay. So, so now here is one very important conclusion. We got t is 30 seconds and t is 10 seconds. Okay. So which t I need to use? This is really a good, what I could say, good conclusion which I wanted to say. Okay, just listen. This is not very important with respect to this problem, but for understanding conceptually. Okay, that is why I am explaining this. So a particle is starting to move, right? Initially somewhere is there where the distance was 0, time was 0. Okay, 0 second, it is starting to move. As it is moving, okay, as it is moving in a straight line only, as they said that it is moving in a straight line only, it will be keep on moving, but it is decelerating. Okay, which means velocity will be continuously decreasing. It is initially 2 meter per second, then it will reduce 1.9 maybe, and 1.8, then 1.7, keep on decreasing, and at one particular point its velocity will become 0. Am I right? That obviously is going to happen if velocity continuously decreases. And from there, deceleration was minus 0.1 1 meter, right? Which means it has to, once it reaches this point, okay, once it reaches this point, the particle will start moving backward, okay, with an acceleration of 1 meter per second square. Okay, here it has 0 meter per second velocity. Now it is moving backward because deceleration is deceleration is 0.1 meter per second square. So it start moving backward. It will keep on moving backward. Now the question is what? The question is they are asking from the starting point, what is the time taken to reach the point which is at a distance of 15 meters, right? So time after which the particle is 15 meter away from the starting point. So this is the starting point, and let us consider this is the 15 meter. Okay, 15 meter away. So obviously this particular position, okay, this particular position you could see two times, okay, two times the particle is crossing. One time will be the first time when it is moving this direction, and second time when it is moving back because of deceleration. Because of deceleration, the particle is moving back, right? So that time also it will cross that particular distance. Okay, so listen carefully. They are asking what is the time taken after which the particle is 15 meters away from the starting point. So it will be away from the starting point, 15 meter away from the starting point, when it is moving this side. Okay, when it is moving this side at some particular time, it will be there. Okay, at that position. And when it is moving back also, why it is moving back? Because it is decelerating. Okay, decelerating, constant deceleration is happening. So after it becomes 0 meter per second, again it will be coming back. Okay, again it will be coming back. This is something which is similar to we are going to discuss in the next concept. That is, if I have a ball, if I throw it upward, it will reach, and it will reach a velocity of 0 meter per second. Again it will come back, and again it will reach it will reach the ground, similar to that case. So this point, okay, this point, that is a point which is at 15 meters from the starting point, this point will be covered two times. One time when the particle is moving left to right, another time when the particle is moving right to left. So we got two answers, right? So one is 10 seconds, I'm sorry. One is 10 seconds, I'm very sorry. And another one was 30 seconds. So when it is moving left to right, the time was 10 seconds. When it is moving right to left, the time was 30 seconds. So for this question, there is no 30 seconds. So correct answer was 10. But there is a possibility for MSQ question, multiple select question here. Suppose A is 10, B is 20, C is 30, and D is 40. Then A is also correct answer, C is also correct answer. So both A comma C is correct. They can ask MSQ from this. This is MCQ, no issues at all. If they ask MSQ multiple select question, these types of questions are possible. Okay, so you have to understand the basic concept. When it is moving this side, it passes through the same point. When it is coming back also, it passes through the same point. That is the point which is present at 15 meters from the starting point. Okay. So let us discuss another question from kinematics of particles. We are discussing the concepts related to three equations which we derived, right? Equation of motions. Okay. So a police jeep is chasing a culprit going on a motor bike. Okay. So there is a culprit who is going on a motorbike, and police is coming in a jeep. The motorbike crosses a turning. Okay, so let us consider this is the turning. Okay, so this is the turning, and the motorbike crosses the turning at a speed of 72 km per hour, and jeeps follows it at a speed of 90 km per hour, and crossing the turning 10 seconds later than that of bike. Let us take something like that. At time is equal to 0 second. Let us consider this is the starting point, so that we can, it's very easy for us to analyze. Okay, so at time is equal to 0 second, what is that? Motorbike is crossing the turning. Okay, it is crossing the turning, and it is moving in this direction. After 10 seconds only, okay, after 10 seconds only, jeep is crossing the turning. Okay, so after 10 seconds only, jeep is crossing the turning. So let us take that, what is that, the jeep. Okay, time to be 10 seconds. It is reaching after 10 seconds only. Okay, now the question is, let us go to the question. Assuming that they travel at a constant speed, very important point to note. Assuming that they travel at a constant speed. Okay, so if they travel at a constant speed, what does it mean? Velocity is constant. So if velocity is constant, acceleration will be what? It is zero. So there is no acceleration, no deceleration, nothing. So acceleration is zero. Now the question is, how far from the turning will the jeep catch up with the bike? See, obviously, jeep is traveling at a velocity 90 km per hour, right? So let me take it like this: jeep, and then what is that? Motorbike, right? So Jeep's velocity, the constant velocity, it is traveling at a constant velocity 90 km per hour. And bike, okay, this is traveling at a velocity 72 km per hour. Okay. Now the question is, Jeep is traveling at 90 km per hour. The bike is traveling at 72 km per hour, constant velocities. So obviously, Jeep will cross over the bike. So Jeep is traveling at 90 kilometer. So bike is traveling at 72 kilometer per hour. So obviously, Jeep will catch the bike. So now they are asking from the turning. Okay, this is the turning, right? So this is the turning. So from the turning, what is the distance? Okay, let me take. Sorry, they're not asking the distance. Yeah, they are asking the distance from the turning. What is the distance at which bike and like Jeep will meet? Which is nothing but Jeep will catch the bike. When time is equal to 0 second, bike was here. And when time is equal to 10 second, Jeep was here. So when time is equal to 10 second, bike will be here, right? Am I right? That is, bike would have traveled some distance. I hope it is clear. Initially, when time is equal to 0, bike was there. Bike was continuously moving. After 10 second, bike will reach here. And now at time is equal to 10 second only, Jeep is entering that position. Okay, Jeep is entering. At time is equal to 0, bike was there. At time is equal to 10, Jeep was here. And time is equal to 10, bike was here. Okay, I hope it is clear. Okay, so at 10 seconds, Jeep was at the initial position, bike was at some position which is away from which is not which is away from Jeep. Okay, now the question is, what is the distance from turning so that the Jeep will catch the bike? So how to determine it? That is something. This is really a good question. Okay, it's not that easy question also. Very good question. We will discuss it. So first of all, both Jeep and bike has to travel a distance of x meter, right? Because that's what we are assuming, at a distance of x from the turning, Jeep is catching the bike, and bike is traveling at a speed of, okay, bike is traveling at a speed of that is velocity, okay, velocity of the bike with 72 kilometer per hour. You can convert it into meter per second if you wish to. If I convert, what will happen? 72 kilometer per hour, approximately it will be 20 meter per second. Okay, 72 into, let me just give you the way, okay, give you the method. 72 into 10 power 3 kilometers, 10 power 3, right? Hours is 3600. Okay, just cancel it, so that finally you will be ending up with 20. Okay, similarly 10 power multiplied by 10 power 3 divided by 360 with this 990 kilometer per hour also, you will be getting 25 meter per second. Okay, so let me just write it down here. So this is going to be 20 meter per second. And see, Jeep should also cover the same distance. Okay, Jeep should also cover the same distance x. Okay, but with the speed what? With the speed of vj, with the speed of 25 meter per second. You just multiply with 10 power 3 and divide it with 3600 to get it. Okay, now the question is, what about the time taken? Both are covering same distance, but both are traveling at a different velocity. So obviously, the time taken. Let us assume that Jeep is. Let us assume that for bike. Okay, let us assume for bike it is taking t seconds to reach this particular point. Okay, bike is taking t seconds. Okay, to travel x distance. What Jeep will take? How much time Jeep will take? Very simple. If bike takes t seconds to cover the distance x, Jeep should take t minus 10 seconds to cover the same distance. Then only they can meet at this point, which means then only Jeep can catch the bike. Let me repeat it. Listen carefully. If bike takes, okay, if bike takes, if bike takes t seconds to cover x distance, okay, bike, like, let me consider this is the turning. For covering this x distance, it is taking t seconds. Okay, now here already bike has traveled some distance now at 10 seconds. Okay, so but Jeep was present at this point only at 10th second. Okay, only at 10th second only Jeep is present. Now Jeep should also cover the same distance x, and it should catch the bike. If it should catch the bike, then Jeep should cover the same distance at a time t minus 10, right? Because total time bike has taken to cover was t, so total time Jeep has to take should be t minus 10. I hope it is clear. So the time taken for jeep to cover the same distance should be t minus 10. So this is going to be t, let me take it as t, which is equal to tb, which is equal to t, and this is time taken to cover the same distance x by the jeep, which is going to be t minus 10. Okay, now what is the case? They are covering same distance, right? So x will be equal to x. First let me use this formula. X is equal to ut plus 1 by 2 at square. We already know that acceleration is 0. Okay, we already know that acceleration is 0. So this is 0. So s is going to be simply u into t. Okay, so let me erase this. So simply what will happen? Simply what will happen? I can just u initial velocity, here velocity is anyways constant, so initial velocity into t, so vb into t, okay, vb into t, which is equal to x, and that should be equal to vj into t minus vj into t minus 10. Let me repeat, bike takes t second to cover, and jeep should take t minus 10 second to cover the same distance x. Then only it can catch, then only it can catch the bike, right? Because jeep was lagging by 10 second, so it should cover the same distance at a time t minus 10, then only it can catch the bike. Okay, so 20 into t, which is equal to vj, is how much? 25 t minus 250. I'm just multiplying this 25 inside. Okay, so 25 t minus 250, I'm bringing this to this side, so 250 is equal to 5t, so this is going to be 50. Okay, so 50 meters, right? Am I right? It is 50 or what? 50 seconds, I'm sorry. So time taken was 50 seconds. We need to find out what? We need to find out the distance, right? What is the distance? We need to find out x. X is simply 20 into 50. Okay, 20 is VB, time is 50. So that's going to be 1000 meters, which is nothing but 1 kilometer. 1000 meter means 1 kilometer. One small logic you need to understand, since Jeep is lagging by 10 seconds, the distance the motorbike is covering, the same distance Jeep should cover at a time t minus t. This distance motorbike is covering at t second, same distance Jeep should cover at t minus 10. I'm very sorry, t minus 10. That is something, that is the only logic in this question. If you understand that, this question is done. A car is starting from rest, is accelerated. The acceleration of the car at any instant is 10 by v plus 1, where v is the velocity of the car in meter per second at that instant. Very good question, and there is a big possibility for you to do mistake. They are asking the distance at which the car will attain a velocity. Okay, so velocity of 36 kilometer per hour. So final velocity is there. Can I use this formula? This is something which we used continuously, or any other formula, v is equal to u plus at, or v square is equal to u square plus 2as. I guess I can use this formula, right? Because initially rest, so this will become 0, or even I can, yeah, I can use this formula. Velocity, final velocity is 36 km per hour. Acceleration is also there, substitute it, and can I find out s? If you say yes, then it's completely wrong. See, we already know that these formulas are applicable only one and only if acceleration is constant. But in this particular question, acceleration is not constant. Acceleration is equal to 10 by v plus 1. If velocity varies, acceleration will also vary. We know that velocity is varying. Initially velocity was 0, finally velocity was 36. So velocity is increasing from 0 to 36 km per hour. So obviously acceleration is also varying. So I cannot use this formula. I need to go for the basic formula. What is that? V is equal to ds by dt, and A is equal to, I'm sorry, A is equal to dv by dt. Okay. But if you observe the problem properly, there is no time component in the question, no time component, which means I will try to use an equation which doesn't have a time component. What is that equation? dt is equal to ds by v. Again, dt is equal to dv by a. By combining this two, I can write ds by v is equal to dv by a. Okay, So now I will keep all the velocity term one side. So a ds is equal to v dv. Okay, let it be. Now we know acceleration is 10 by v plus 1, right? So acceleration is 10 by v plus 1, and ds I don't know, let it be, which is equal to velocity into dv. That's it. The problem is almost done. Now we have, I will just bring all the velocity term to one side. We are doing that variable separable method, which we did it in differential equation. So I'm just bringing this I'm sorry, I'm very sorry, I'm just bringing this v plus 1. Okay, I'm just bringing this v plus 1 to that side. Okay, so if I do that, uh, 10 into ds will be equal to v into v plus 1 into ds. That is going to be v square plus v into ds, sorry, dv, I'm very sorry, dv. Okay, this side we have dv, right? So this is 10 into ds. Now if I integrate it, okay, so integration of ds, integration of v square plus v into dv. Now the question is, what about the limit? What about the limit? Yes, initially let me take s to be 0 at the initial point, and finally when velocity reaches 36 km per hour, it is s. What about the limits of initial and final velocity? Initial velocity anyway 0, no issues, but what about final velocity? 36 km per hour. Can I use directly 36 km per hour here? I should not use. This is where you have to see the unit. You have to see the unit. Unit of acceleration is given as meter per second square. So when I'm using this, I am using it in meter per second square. So wherever unit of velocity comes, I need to use meter per second only. And wherever unit of displacement comes, I need to use meter only. So displacement will be in terms of meter. So this is 0 meter per second. This is 0 meter, and here the final velocity should be in meter per second. So 36 kilometer means 36 into 10 to the power of 3, that is 1000 by 3600. So I can simply cancel this, so it becomes 10. So 0 to 10. Okay, so now by integrating it, v cube by 3 plus v square by 2, upper limit is 10 and lower limit is 0. That's going to be equal to 10 into s only, right? S minus 0. Now solve this, I'll be getting s, upper limit is 10, so you just substitute the 10 here and take LCM and find out the value, and then bring that 10 this side. Okay, so finally I'll be getting 38.33 meters. Okay, so 38.33 meters. Okay.